loop configuration. So what is meant by open loop configuration? Or when we say the device is connected or operating in the open loop. So any device, if there is any sort of feedback or connection from output to the input, then it is said to be without any feedback. If there is no connection from output to input, any sort of connection from the output to input, then it is said to be operating in open loop configuration. It may be op amp, or it may be BJT, or it may be MOSFET, or whatever may be the device. So when we say it is operating in open loop, so there is no connection from the output of the circuit to the input, then we will say it is operating in open loop, or we will say it is operating without any feedback. So such configuration is called open loop configuration. You see, so at the input terminals we have applied two voltages, one to the non-inverting terminal, the other to the inverting terminal, and output. Here we are taking the output, right? So there is no connection from output to the input, So such a configuration is called open loop configuration, or it is said to be operating in the open loop mode. So in open loop configuration, or in open loop, we have three configurations. We have total three configurations, and when the op amp is operating in open loop configuration, it will have or simply function as high gain amplifier. So whenever the op amp is operating in open loop, the op amp simply function as a high gain amplifier, because the gain of the op amp is very high. Gain of the op amp is of the order of 10 power of 6. So it is a very high gain amplifier. So the op amp in open loop can configure, we can operate the op amp in open loop in three different configurations. Again, in three different configurations, we can operate the op amp in three configurations. First one is the differential amplifier, second one is the inverting amplifier, and third one is the non-inverting amplifier. So how this amplifiers, these three amplifiers are differentiated. How these three amplifiers are differentiated? That means how it is differentiated means the number of inputs used, and to which terminal the input is applied. So these three configurations, or these three amplifiers, we differentiate based on the number of inputs used, because we have total two inputs. Only for differential amplifier we will use the two inputs. For inverting and non-inverting, for these two we will use only one input. And this, in this inverting and non-inverting amplifier, are differentiated to which terminal the input is applied. So based on this, we are going to classify the open loop configuration. We will look at into one by one. So as you can see, so the output voltage, this is the relationship between the output voltage, input voltages. This is the relation. V0 is simply AD we can take here. So there is a mistake here, sorry. V0 is equal to AD into V in 1 minus V in 2. So here generally this R in 1 and R in 2 are source resistances, and these are normally negligible when compared to input resistance of the op amp, because input resistance of the op amp is again very high. It is of the order of mega ohms, whereas these are in fact very small. They are in the range of some 100 to 1000 ohms. So when compared to input resistance of the op amp, so this we can neglect. So there is almost negligible voltage drop. So whatever input voltage that we are applying, So we can take VD simply V in 1 minus V in 2. We can neglect the drop across these two resistance because they are negligible when compared to input resistance of the op amp. So VD, differential voltage at the input terminals of the op amp, is simply V in 1 minus V in 2. So we can neglect the drop. VD is simply nothing but V in 1 minus V in 2. So that's why we are writing the output voltage. Output voltage is nothing but what is the relationship between output voltage and input voltage of the op amp. V naught is nothing but it is AD into VD, right? So here VD, you can approximately write it as V in 1 minus V in 2. So that's why V naught, we can write it as AD or simply a V in 1 minus V in 2. So this is the open loop voltage gain of the op amp. So open loop voltage gain of the op amp. Open loop voltage gain of the op amp. So we'll look at the one by one configuration. So what is the limitation? What is the limitation in when we are operating in the open loop configuration means? So the voltage we need to apply very small. The voltage we need to apply is very small. The voltage we need to apply is very small. You see, it is of the range of microvolts. It is of the range of tens of microvolts because the gain of the op amp is 10 power of 6. 10 power of 6. So if you multiply the microvolts, micro means 10 power of minus 6. So any voltage that you apply greater than microvolts will make the output of the op amp into saturation. Will make the drives the op amp output into saturation. So due to why what is the reason? It is due to high gain of the op amp. The gain of the op amp is 10 power of 6. So any voltage you apply greater than the range of the microvolts, so it will drives the op amp output into the saturation. What is the saturation? The saturation voltages are nothing but it is less than or equal to the supply voltages. Because this is the maximum input that we are supplying to the op amp. So the output, in order to satisfy the law of conservation of energy, the output will never be greater than what input we are giving or we are supplying to the circuit. So supply voltage is the maximum voltage that we are applying to the op amp. So the output voltage, this plus or minus Vsat, will always be less than this plus or minus Vcc. Apart from output, there is power consumption, right? So some power will be consumed. There is some power consumption for proper operating of the op amp. So this saturation voltages will always be less than or equal to the supply voltage. So the limitation is you always need to apply voltage less than microvolts range. If you apply any voltage that is greater than plus or minus tens of microvolts, will drive the op amp into saturation. So that's why, so it is this open loop configuration of op amp is not suitable for linear application. So it is suitable, or we can have only the non-linear applications. Non-linear applications. So when we are operating the op amp in open loop, so always we'll have non-linear applications like comparator and window detector. So this we will see in later classes. So but the applications are comparator and window. Only limited applications, very few applications will have when we are operating the op amp in open loop configuration. So this you need to remember. So here the important point is you need to apply the voltage of the range of tens of microvolts. So that is the first point, and you will have very limited applications, right? Now, what is the transfer characteristics? How the relation between the output and input voltage will look like? So how the output voltage and the output voltage, and here we are taking the differential voltage, input differential voltage, and we are drawing transfer characteristics means it is the relationship between the output and input. So we'll see So this is how the characteristics of the transfer characteristics of the op amp will look like. Transfer characteristic. So very small portion, a very small portion of input voltage range. This differential voltage may be positive or negative. We can apply positive voltage or negative voltage, but this region is very narrow, region. This linear region, this region is nothing but the linear region. Linear region. Why it is linear region? So there is a linear relationship between the output and input. So why, when will we say the region is linear or it is operating in linear mode? When the output is proportional to the input. If output is proportional to the input linearly, then it is called linear region. So when the op amp is operated in open loop configuration, only for a small, very narrow region, it will operate in the linear region. So apart, if it crosses this range, so the output is simply either plus Vsat or minus Vsat. So if the input voltage that you are applying crosses this limits, this linear region limits, the output will simply either, depending upon the polarity, if you are applying positive differential voltage, if the differential voltage is positive, then it will go into the plus Vsat, and if the differential voltage is negative, simply it will go to the minus Vsat. The output will switch either plus Vsat or minus Vsat. Apart from this linear region, simply the output will switch between this plus Vsat, and minus Vsat voltages. So that's why it is very narrow region of operation. So if you apply any voltage that is greater than this range, so it simply, the output voltage switches between either plus Vsat or minus Vsat. So this is how the transfer characteristics of the op amp will look like when the op amp is operating in the open loop configuration. Now we will see that three different cases. First one is a differential amplifier. So here we'll apply inputs to both the terminals. So V in 1 or V1, and then this is connected to ground, and here also we'll see why one terminal is called inverting and why it is called the second terminal is non-inverting in this module. So this is R in 1 and R in 2, and here we'll take the V0. So the output voltage, so if these inputs are not zero, then the output voltage V0 is simply A into V1 minus V2, because the output is proportional to the difference between the input voltages that we are applying. Output voltage is simply proportional to the difference between the input voltages that we are applying. So that is why it is called differential amplifier. So for differential amplifier, this input voltages should not be equal to 0. We have to apply both voltages to the non-inverting and inverting terminal. So as the output is proportional to the difference between the input voltages that we are applying, so that is why it is called differential amplifier. The output is proportional to the difference between the two input voltages that we are applying. So that is why it is called differential amplifier. Now second one, inverting amplifier. So when will we say inverting amplifier? So to one or this terminal, this non-inverting terminal, we are not applying any voltage, only to the inverting terminal. We are applying the voltage. So the output voltage, actually what is the relation? V0 is nothing but A into V in 1 minus V in 2. A into V in 1 minus V into. Now we are not applying V in 1. V in 1 in this case it is 0. So the output voltage, what is output voltage? Now it is becoming, it is minus A into V in 2. Now why it is called inverting amplifier? Why it is called inverting amplifier? For example, if you are applying V in some positive voltage, if we are applying V into some positive voltage, what is happening to V out? V out is simply negative voltage. V out is simply negative voltage. We are applying positive voltage and the output is nothing but simply negative voltage. For example, if you are applying input voltage, some negative potential, whereas output is simply becoming positive potential. So that means there is an inversion relationship between the input voltage that we are applying and the output voltage that we are getting. So if you are applying positive voltage, we are getting output voltage negative. If you are applying negative voltage, we are getting positive voltage. So there is a 180 degrees inversion, 180 degrees inversion between 180 degrees phase shift between input and output. So whatever maybe, if you are applying positive, you are getting negative. If you are applying negative, you are getting positive. So that's why, so whenever we are applying to this terminal, the output voltage is getting inverted in polarity. So that's why it is called inverting amplifier. So that's why this configuration is called inverting amplifier. If E in 1 is equal to 0, so the output is getting inverted. So that's why this configuration is called inverting amplifier. Next, non-inverting amplifier. In non-inverting amplifier, so to this second terminal, we are not going to apply any voltage. Only to the first terminal, we are applying the input voltage. Only to the first terminal, we are applying the input voltage. So in this case, V naught, as V naught is given by A into V in 1 minus V into, so V into is 0, V into is 0 in this configuration. So the output voltage is simply proportional to the input voltage. So if V in 1, if V in 1 is positive, if V in 1 is positive, then V naught is also positive voltage. If V in 1 is negative voltage, if V in 1 is negative voltage and V naught is simply negative voltage. So the output is simply proportional to the voltage that you are applying at this terminal. So that is why it is not inverting. It is not inverting. Whatever voltage you are applying at the input, the same polarity you are getting at the output also. So that's why this is called non-inverting amplifier. There is no inversion relationship between the output and input. So that's why this is called non-inverting amplifier. That is why this is called non-inverting amplifier, right? So whenever there is a inversion relationship, whether it is open loop or closed loop, then such amplifier is called inverting amplifier. So whenever there is no inversion relationship between the output voltage and input voltage, then it is called non-inverting amplifier. So whenever there is the output voltage simply proportional to the difference of V in 1 minus V in 2, then it is called differential amplifier. Differential amplifier. So this is how we classify, or the operational amplifier will operate in any one configuration mode. It may be differential amplifier, it may be inverting amplifier, it may be non-inverting amplifier. But these we will see in closed loop also.
If you like the video, please share, like and subscribe. Hit the bell icon to get latest video updates.